Hey Alberta, Mark Doran here for the Polluter Pay Federation. I'm doing a series of videos at election time, Alberta, April, May 2023, to bring awareness to the fact that our Alberta energy regulator needs to be reformed. So I want to focus here on something that has been shown by a study that the Alberta energy regulator itself commissioned, which is that 96% of Alberta oil and gas storage tank operations are unsafe and illegal in the province. This is just part of a basic oil and gas operations series that I'm going to be doing. In Alberta, oil and gas operators that operate on someone else's land, on a host landowner's land, they're required to explain the nature of their operations to the host landowner. They're also required to explain the safety rules and to ensure that that landowner understands the risks, and for obvious reasons. Landowners aren't necessarily familiar with oil and gas operations, so they're just not doing it. Well, licensees just aren't living up to their responsibilities in Alberta in this and many other ways. So, and also people that are involved in trying to reduce emissions, climate change people, people that believe in something called methane emissions. This will explain that methane is not necessarily the problem. It's heavier hydrocarbons that are the problem, that are emitting from these storage tanks, which are really all over North America and in some places beyond North America. So let's get going. Let's get going and move on and discuss this. So basic overview. In this presentation, I'm going to be dealing with what is basic separation in an oil or gas at a well site or in basic oil and gas production operations. This is going to take review of some really simple basic hydrocarbon chemistry. If you understand the chemistry, it all makes much better sense. Hydrocarbons, which are oil and gas, can be liquids or they can be in the gaseous phase, and that's what we're going to be dealing with here. And throughout discussing this, one will be able to learn what an oil well solution gas is in simple terms. So we also have gas conservation, particularly at oil well production sites. So gas conservation means the opposite of flaring or burning that gas. So, you know, in the past, we've burned gas a lot, and in some places in the world, in the Middle East, etc., sometimes they still burn all the gas they produce simply because there's no pipelines or means to capture that gas or to transport it so that it can be used for some useful purpose other than just wasting it or burning it. So gas conservation means not burning or wasting the gas. So let's get into basic separation and simple hydrocarbons. The goals here are public safety and to eliminate fugitive hydrocarbon emissions, mainly so they don't cause safety hazards, explosion hazards. So at the top, I've drawn hydrocarbons, simple hydrocarbon molecules. All oil and gas are hydrocarbons. It's just a question of how light or how heavy those hydrocarbons are. So how many hydrogen and carbon atoms there are in the molecule. So they're all constructed in a similar fashion, which means that there is a carbon atom, which I've shown in blue here with a C, and a hydrogen atoms surrounding that carbon atom. So let's start with methane. We call it C1 in the industry. That means simply it has one carbon atom and it's surrounded by 4 hydrogen atoms. The next heavier natural gas molecule is called ethane, and it's called C2 or C2H6. And so it's 2 hydrocarbons surrounded by 6 hydrogen atoms, etc. The next one's propane, commonly used in your barbecues, C3H8. Then we get into the butanes, then there's pentanes, octanes, and heavier molecules. So most separators at oil and gas sites operate at around 50 psi, and at that pressure, methane and ethane, which are the 2 components of natural gas that's distributed to people's homes, those gases will definitely be in the gaseous phase at temperature, at pressures like 50 psi or even much higher. Whereas propane and heavier ones, propane and heavier, anything heavier than ethane, they're going to be in a liquid phase at 50 psi. So what happens? There are rules in Alberta, definitely, and probably elsewhere, that all gas produced by a gas well or by an oil well, there's always, almost always, some gas produced with oil. You have a mixture of hydrocarbons is what you're producing from these wells always. Is this gas must be measured by law. Now, it's not possible to measure liquids and gases together, so they must be separated. And to do that, we use a separator, and I've chose to show a horizontal separator here. They can be vertical as well, but in a horizontal separator, you usually have something called a weir, which is a divides the separators into two chambers, but it doesn't go all the way to the top of the vessel. So let's get I got a little bit of animation here. So the oil effluents that get produced by the well, they go to the inlet of the separator. So I'm showing them in green here, and oil effluents are oil or other liquid hydrocarbons, water, dissolved solids like salt in the water, and gas. So this mixture, this jumbled up mixture, comes in a pipeline and into the inlet of the separator. So the separator is larger in diameter, so the rate slows down, and it gives these various liquids and gases and components of liquids time to separate from each other. And this can happen in a heated treater too, where if there's some emulsion or oil and water that are mixed together, the heat helps break that emulsion. So the white dotted line, that shows an interface between oil, which would rise to the top, and water, which is heavier, which would sink to the bottom. And there's level controllers, and on valves, like these valves here show level control. So what happens is that you maintain a level between the oil water interface below the weir, and the oil pours over the top of the weir, like I've shown with this brown arrow. And then another level is maintained here by this valve, which opens to dump liquids, oil and C3 plus, or oil and anything heavier than propane and heavier, out to the tank. We'll come back to that. So there's a level control also for the interface, and a water outlet connected to a valve here that allows that water to go out to, presumably, to water disposal somewhere, or to a tank to be trucked away for water disposal. Can happen a lot of different ways. So we'll move on, and we'll deal now with gas. So gas is the lightest, it rises to the top, and we have a back pressure valve here, and then that gas must be flared by law or conserved. We'll come to conservation next. So, and the reason that it must be flared or burned is so that it doesn't build up in explosive mixture. So if someone drives through or comes along with a source of ignition, and those unburned hydrocarbons are within 5 to 15% mixture in air, they can explode. So that's a public safety matter. So if we have a controlled burn, we eliminate the explosion hazard. So gas, which in this case are methane and ethane, they're the ones that are in the gaseous phase, they're burned. So those aren't being emitted in the form of methane. That's a worse greenhouse gas than CO2. So when we burn it, we convert it to heat, water, and CO2, right? So we'll come back to now. What we have is that because these propane, they're liquid in the tank, but the moment they cross this valve here that I'm showing with the level controller, they change phase because your temperature decreases. So we have 50 psi in the tank, psi in the separator, and 0 in the tank. So it's just like a butane lighter. If you press the lever, it goes, and that butane that's in a liquid form at a pressure just slightly higher than atmospheric or room pressure will change phase and turn to a gas when it's released. So the same thing is happening in this storage tank here. So to illustrate that, I've shown these gases that are now solution gases. They're in solution in the, so it means in liquid form in the separator. They go to the tank in liquid form, and depending on the temperature, in the wintertime, they might not all change phase, but in the summertime when it's hotter, there's more of them that are going to change phase, and there's more emissions going to come off, and they'll go off to atmosphere, as I've shown by these clouds of C3 plus. And that means propane, butanes, pentanes, etc. plus are going to atmosphere. So there's a solution to that, and we call it vapor recovery. So you just simply tie that tank in through a flame arrestor so that no explosion can go back to the tank. And that's the law in Alberta. So the law in Alberta is that any appreciable amount of gas that's vented to the atmosphere must be burned. Section 8.080 of the oil and gas conservation rules. So that's where the 96% non-compliance comes in, is that most of these tanks that are supposed to be tied to flare, or where the gas should be conserved off those tanks, they're not tied to flare. That's contrary to law. So that's essentially simple hydrocarbon chemistry, simple basic separation. And the point I'm making here is that it's not methane going to atmosphere, it's propane plus, heavier hydrocarbons that are going to atmosphere here, not methane. And some of these cameras, etc., they can only see methane. They can't see propane and heavier hydrocarbons. So that's one of the reasons why this needs to be explained. So what's gas conservation? Well, simply that gas, instead of going to flare, it goes to a pipeline, usually through a compressor. So a compressor is to gas what pumps are to liquid, so that you can take this gas, suck it off the separator, suck it off the tank, add energy to it by way of putting it through a gas compressor, and force it down a pipeline where it can be sent off, processed, used to make propane and heavier hydrocarbon liquid gases, solution gases, sold for use, for heating and for any other use of propane or butanes, put in lighters, etc. So that's gas conservation. So moving on, here is a typical oil well site with storage tanks. So these are pumping oil wells in the foreground. There's more than one of them here. These are the separator buildings. One's here, one's over here. These are vertical separators. So that's the separator vessel, and that's the gas piping coming off the top of it. So in the distance, we can see that there's some storage tanks. So we'll go take a closer look at those. These are the same storage tanks. And what you can see is that these tanks have a U-shaped, C-shaped piping so that rain doesn't get in the tank, but so that gas can vent off. So that's your solution gas, your propanes, butanes, plus coming off the top of the tank, venting to atmosphere there illegally. So what I also wanted to show is that this fence where this farmer can come close to these tanks, it's too close by law. There's possibility for gas to build up here in explosive mixtures, especially on a still day, and get into a mixture where if you drive through with farm machinery, which has countless sources of ignition, that can cause an explosion. And so that's why we have public safety laws that are enforceable by operators at well sites where there's tanks or other sources of ignitable vapor. So one more thing here is that if the gas produced is sweet, in other words, if there's no poisonous hydrogen sulfide component to it, H2S component, then these facilities, most of them can be unlicensed at most Alberta well sites. In other words, the Alberta Energy Regulator is not reviewing the arrangement of tanks, separators, flaring, etc. at the site. They have not approved it. The operator can move these things around at will. There are certain spacing rules. And those spacing rules are self-enforceable. So the operator must self-enforce these spacing laws. And these spacing laws also dictate minimum site area. So most sites I see like this in Alberta are far too small. There's reasons for that. I'll go into a whole separate video on minimum site size. I have a case going to the Court of King's Bench on that soon as well. And well, simply put, landowners just aren't safe farming around most of these sites. Simply put, these sites should be bigger. Simply put, the sites are smaller so that cheap operators that don't care about public safety, don't care about land rights, and these land rights are guaranteed. The right to be safe is guaranteed under the Charter of Rights and Freedoms in Alberta, and we're not paying attention to it. And especially these rinky-dink little operators, well, the big ones too, they're more concerned with making sure they don't have to pay for weed control on these sites than they are with landowner safety. So this needs to end. So, you know, that's some of the reasons why I've done this video. So to sum up, climate change people, you now know that there are heavier hydrocarbons emitting from hundreds of thousands of sites all across Alberta and Saskatchewan, and probably millions of sites in North America. This is why Albertans, if you're landowners, host landowners, you're probably undercompensated. You're more than likely not safe. Learn about this. Join the Polluter Pay Federation. That's the main reason why I've done this video. So I'm just going to quickly share back my screen again and wrap up that the Polluter Pay Federation is a Canadian federal nonprofit corporation. We are for protection of property rights, real property rights, which are surface and mineral rights, and taxpayer protection. Our website's down at the moment, but it'll be back up soon at polluterpayfederation.ca. And learn more about Polluter Pay Federation. We're here to educate landowners. We're here to raise capital so that we can push back against the powerful lobby of the industry. And we're here to try to raise litigation funds to help landowners fight key cases to protect our land rights and to protect our safety and to make sure we're properly compensated. So one last message at election time, 2023 provincial election in Alberta, make sure your MLA, urban and rural, there's lots of well sites like this in urban areas in Alberta. Make sure they're aware of this. Make sure they are committed to Alberta Energy Regulator reform, because this regulator is not protecting our land rights and is not protecting safety. Thanks very much. Be safe out there.